Okay, we're going to go over problems from this worksheet here. Determine whether each equation is a linear equation. Linear, keyword being line, first four letters there, easy to remember. If an equation is linear, rewrite it in the form ax plus by equals c. Let's see who remembers what the name of that form is as I write it down. Okay. What they don't put on here is our normal conditions for A, B, and C. A, B, and C. They're using capital letters here. It can also be written with lowercase letters. Are integers. So no decimals, no fractions. Integers. And A is usually greater than 0. Those are your conditions for most books. Okay, so how do I know if it's linear or not? I look at the x and the y. The exponent on the x and y, or if there's only an x or only a y, it can be like that as well. It doesn't have to have both, it could have one, but if the exponent on it has to be 1 when it's in the numerator. All of these variables here happen to be in the numerator, so they aren't trying to trick you. Okay, so they have to be in the numerator, or if they're in the denominator, I have to move up to numerator, which remember means I take the opposite sign. Okay, so when they're in the numerator, both the x and the y, if there's both of them or either one, it has to be a 1, and they cannot be multiplied together, as in the case here, because that degree of that expression is 2. The degree of each expression is going to be 1. So that means the x and y will never be multiplied together. Okay, they'll be in separate terms. And so notice, oh, I'm not going to give it away. Let's pick one of these that is linear, because then we need to change it into standard form, such as number 6. Notice the x and the y's all are 1 for the exponents. Okay, and the x and y is not multiplied together. They're all in separate terms. Okay, so now we need to put it into this form right here, standard form. Ax plus by, so that means A has to be positive, remember on this. Well, that tells me then I'm going to have to move the 3x across, smaller to the bigger side, so it ends up with a positive. So 5x minus 3x is 2x plus 6y equals negative 2. So I get the x and y terms on one side, the constant on the other. Okay, doesn't matter what side. Okay, we have it right there. There's that answer. Same form as that. All right, graph each equation. Remember, so these are in standard form, these graphs right here. Let's see if the bottom ones are too. Bottom ones are fractions. Let's go ahead and do one with a fraction, one of the harder ones. Okay, so the first thing I want to do, let's do number 10. First thing I want to do is clear the fractions. So I'm going to multiply the entire equation by the common denominator, or the LCM, least common multiple, same thing. What is the common denominator between 2, 4, and remember that's over 1. So 2, 4, and 1, the common denominator is 4, or LCM is 4. So I distribute the 4 through each term. Remember, these are called terms separated by plus or minus signs. And so half of 4 is 2x plus 3/4 of 4 is 3y equals 4 times 1 is 4. Okay, now you could go ahead and put it in a slope-intercept form, solve for y, put it in a slope-intercept form. Or I could go ahead and use, since it's in standard form, the two easiest points to plot in standard form are the x and y intercepts. So x-intercept, remember, is when y is 0. The y-intercept is when x is 0. And I solve for the y. Okay, so if we do the first one, x-intercept, y is 0. Plug in y for 0 right here. I get 2x equals 4, x equals 2. Now I go ahead and move this 0 over to here, plug in 0 for the x, and I get 3y equals 4, or y equals 4 thirds. Okay, there's my 2 points. Remember, I need 2 points to create a line. So 2, 0 right here. And 4, 0, 4/3. 4/3, you need to know that means 1 1/3. So approximately right there, 1 1/3. Then I would take my ruler and connect through those. Okay. And obviously you have a ruler, so you can do it better than I can. It's approximately right there. And arrows at the end for a line. Okay. Yeah, I could have, and we'll go ahead, since I'm just doing one problem here, we could solve this for y and put it in self-intercept form and do it that way. So if I did that, remember I'm solving for y, so I'm subtracting the 2x across, and the last step divide by 3. Okay, so I have y equals negative 2/3 x plus 4/3, or 1 1/3. So here's my 1 1/3, my y-intercept, and it says go down 2, 1, 2, and right 3, 1, 2, 3, and that'd be that point. So I'd have those 2 points, and of course, they are on the same line right there. So if you want to solve for y, that's an example of solving for y. Let me put this clear right there. All right, other side now. Functions. Determine whether each relation is a function. Relation is just a set of points. Okay. And function, since this is graphically, a function must pass the vertical line test. Now, what is the vertical line test? That says if I draw a vertical line anywhere in the graph, it can only cross the graph one time. If it crosses twice, it fails the vertical line test. It's not a function. So example 3, when I draw a vertical line right there, here, here, they fail the vertical line test because they hit the curve twice. It cannot hit it twice, it can only hit it once. So that is not a function. Versus if I did 6, that would be a function. So if I graph vertical lines, it's only hitting one time. Each time, there's no going through 2 points. So that's a yes. That is a function. So that's how you do it graphically. Now down here, 7 through 10 with points, the definition of function is for every x coordinate, that is, there is only one y coordinate, which simply means what I'm looking for is no repeat x's, assuming that the y coordinate on repeat x's is different. Okay, if they want to try to trick you, they could put the same point down twice. Okay, and so if you saw 2 x's and end up having the same 2 y coordinates, it's really the same point. So that wouldn't count. It would be 1 point, even though they've written it down twice. That'd just be a trick. Okay, so you're probably not going to ever see that, but I just wanted to point that out. No repeat x's, so let's just pick one. Say number 9, 1, 1, 1, 1. Oh my goodness, all 4 repeat x's. So therefore, that is not a function. Okay, no repeat x's. So I'm having to check there. On 11 through 16, I'm actually having to graph these different equations here. So you need to plot these. Don't forget, if it's y equals x squared, that's going to be a parabola. X equals, the number is a vertical line. Here's just a linear oblique line. Here's a hyperbola right here when I solve for y and graph it. Here is a horizontal line, and here's a circle from geometry. X squared plus y squared equals 4. or it'd be opposite square root, so it'd be 0, 0 for the center, and the square root of 4 is 2. So you have a circle of radius 2 centered at 0, 0. Okay, and that does it.